what I'm going to talk about today in 20 minutes is really give you an overview of our roadmap technologies, where we are now relative to encryption and data protection in the Azure platform. We've done a lot of work over the past couple of years to really ensure that we are providing world-class leading support for all of our resource provider relative to data protection and encryption for any customer segment. So when we think about encryption trust, just to set up the context for a second, why are we doing that? And there's a lot of misconceptions of why data encryption is good for, especially in a cloud setup. There are a lot of misexpectations that actually encrypting the data at rest provides customer with some additional authorization or authentication capabilities. But the reality is that encryption of data at rest, definitely in a cloud scenarios, whether it's Microsoft or AWS or Google Cloud, is really to prevent or to provide two levels of support. One is what we call physical or offline attacks. As much as we do a lot of work to protect our data centers and ensure that we have the right procedures for data handling and disk handling, things can go wrong for whatever reasons, right? Disk is not shredded properly, insider threats, someone's going to steal disk from our data centers, who knows? So we want to make sure that for any of those type of scenarios, we have good coverage for when your data is stored on our systems. So that's really probably the number one scenario where encryption at rest comes into play. Second is compliance requirements. As companies transition from on-premise to cloud, most compliance requirements still are based on on-prem requirements. So data encryption for PCI or HIPAA, we understand it's a key requirement for many of the customers. So obviously, we're going to support it across our entire workloads. So when we talk about encryption at rest, it's important to kind of understand what it means and what we can and can't do once your data is protected or encrypted. So let's start from the kind of the right side. And we in Microsoft, we call it encryption models. It helps us ensure we have consistent implementation of those models across all of our workloads, whether it's Azure Storage, SQL, data lakes, HD Insights, RVM encryption, media services, you name it. So we wanted to make sure that as we build our cloud, as we build our security platform in the cloud, we do it in a way that's consistent, and we've implemented implementing the same encryption models across all of our workloads. So starting from the right, this is maybe the most easiest one to understand. This is what we call the client encryption. Client encryption means that all the encryption and decryption operation, key management of the data happens within the customer premise. It can be on a VM that runs in the cloud, but runs within your context, or it's something that then can happen completely on-premise, not in our data centers. We, as the cloud operator, in that case, don't have any access to the keys, any access to the data. No matter what, all we see or can see is really just an encrypted blob, right? That's really what we can do at that point. Those models work for some of our services, like backup and Store Simple and some of the client-based services. But we also provide SDKs for storage and SQL, such that you can build client encryption within your workload. And you can decide that you manage the keys on-prem versus in the cloud. And you can decide exactly who has access to your data and keys. So on one hand, this model is very powerful in the sense that you have full control over everything. On the other hand, that model means that we, as a cloud provider, have no access to the data, and we can't do anything with it. So we can't provide any value add, such as machine learning, HD Insight, or MapReduce, or any additional functionality that we can normally provide you as PaaS services on top of the cloud. We basically just dump storage at this point, and we see encrypted blobs. The other models, which is a bit more interesting, this is what we call server encryption models. In the server encryption models, the encryption and decryption operations happen on the resource provider itself. Whether it's Azure Storage, SQL, data lakes, and whatnot, the encryption happens on the workload. And then there are a couple of modes for that. One is what we call with service-managed keys. Server-side encryption using service-managed keys means that for customers that care about the checkbox feature, it's like, well, I don't really care about the key management. I don't care exactly How do you back it up? How do you storage? How often do you rotate it? But I trust you. I trust with Microsoft that you're doing the right thing. I trust you that you're rotating the keys based on your best practices. I trust you that you are storing it safely. I just need the checkbox from my auditor or for my CSO to tell them that my data is encrypted at rest. So that's that model. There is no work for you as a customer. We do all the work. You just say, yes, I want my storage blob encrypted, or I want my SQL DB encrypted. The pros and cons is that, so first, it's encrypted by default. It's just there. You don't have to do much. You don't have to manage key lifecycle or anything like that. And you can enjoy all of the benefits of PaaS services in the cloud. Again, like machine learning, HD insights, and so forth. The downside, again, is that you don't have visibility necessarily to the keys. You don't have control over the keys. And if you need more of that control, you probably want to look at something a bit more advanced or models that are a bit more complete. The second one, which is the one that most customers that use those services in Azure use, is what we call encryption using customer managed keys. And in that model, what happens is all the encryption and decrypt operations happen on the workload itself, but the keys that we're using for that are stored in the customer key vault. Meaning that you as a customer, you have full control over the keys. You decide who has access to them. You can fully audit them. You can rotate or revoke them when you choose to, right? But the workload itself, when it needs to decrypt or decrypt the data, it reaches up to the key vault and says, can you please give me the key or unwrap some other key so I can actually access the data? So the pros here is that you, of course, have full control over the keys. You decide who has access to it. But you're also responsible for the lifecycle management of this key. You decide when to revoke it. You need to decide when to renew those keys. You need to decide who has access to these keys, to audit them, and so on and so forth. So again, it's way more powerful in that regards, but on the other hand, it requires more work. The last model, which is debatable, and we can have more debates after whether it's actually useful or not, is a model where we say, all the data is encrypted in the cloud. The server workload does all the work, but the key itself is stored on-premise. It's not stored in the cloud. It's not stored in our data center. It's stored on your own HSM in your own premise. And then there is a discussion how useful it really is if the data need to shuttle back and forth from the cloud, or the keys need to come back to the data center so we can decrypt the data. So the models that we normally recommend are either the client encryption or the two server encryption models where we manage the keys or you manage the keys in Key Vault. The next thing that we did before we kind of implemented encryption across all workload in Azure, we said, so what are the promises that we want to make customers relative to their data and keys? And we said, well, there are really two key areas that we want to focus on. One is what we called the control, and the other is transparency. And everything I'm saying here relates to any service or any workload in Azure that implements that. So first and foremost, you decide if and where the data is encrypted. You decide where it is stored. There's a lot of sovereign or local requirements relative to where the data is stored. Can it live only in Europe? Can it live only in the US? Can the data move between sovereign clouds? So there are a lot of requirements that now starting to generate from as companies move to the cloud relative to where the data is stored and who can access it. You can decide at any point of time to check who has access to the data, who has access to the keys, to audit everything we do, and to request everything from Microsoft. So we believe in a model where it says full transparency, whether it's from our internal operators or for you as customers. Next is at the high level, excuse me, what's the high-level architecture of encryption in our cloud? And again, it's a simplified view, but it provides us at least the high-level components, and again, they apply for all services in Azure. So at the bottom, there is what we call the resource provider. The resource provider is exactly what provides you the data service itself. It can be Azure Storage, it can be SQL, it can be Data Lake, it can be media services, it can be machine learning, it can be Hadoop clusters, it can be anything that eventually stores and manages the data on behalf of you as a customer. Then we have what we call kind of the key hierarchy. Again, pretty standard key hierarchy, where we have what's called a data encryption key. That's usually going to be a symmetric key that's actually being used to encrypt and decrypt the data. And then we have set of one or more key encryption keys that wrap those keys and eventually store it somewhere. In the model where the key is managed in the customer key vault, then you have your key vaults, which are governed by Active Directory for access management and control. In a world where keys are managed by the service, then usually it's going to terminate here, and then we have other ways to kind of store the root key for that used to encrypt the data. So that's the very high level how architecture works, and again, that applies to all of our workloads in the cloud. So then we went and said, okay, now we need to apply those models and promises and encryption models to all the workloads we have in the cloud. So we pretty much took a very broad approach. We started the process a few years ago, and we said that we want to ensure that the implementation is consistent across all of the workloads, such that from customer perspective, you have the exact same interaction, exact same implementation of all the workloads. So those are just some of the workloads that support encryption at rest today. And what I want to show you now is really the slide that talks to, this is one of the more detailed slides that kind of, it's kind of an eye chart, but it gives you the view of all of the services that we have today in Azure that supports encryption and how they map to the various implementation models. So we try to break it down into different high-level buckets, what we call Cortana analytics services, where we have the services such as machine learning, stream analytics, data lake stores, and so forth. What we call OLTP, which is the classic disk encryption, storage, SQL, DocumentDB, Store Simple and Backup, IoT, and media services. There are, of course, more services that support encryption at rest. Those are just the high-level ones that I want to call out here. And the way that we called it out is to try and map how each one of those services support the various encryption models that I highlighted earlier. So what you can see is where we are today, and by the way, I don't know if you've seen the blog, we released it this week, but storage, and I guess I need to update this slide, but storage tables is also now supporting encryption at rest, so that's also should be green now. But other than that, you can see we have pretty complete coverage. Everything in green is already implemented, and it's already in GA, and you can use it today. Everything in yellow should light up within the next 3 to 6 months, right? So trying to give you a little bit of the roadmap where we are and when we're going to have full coverage. Some of those just don't make sense for server encryption, for example, Store Simple and Backup, which are by design kind of client encryption model set of services that run on-prem and use the cloud just for storage purposes. So what you can see is that we have pretty complete coverage for all the services that require encryption at rest. Everything here that's in yellow, it's either in private preview, public preview, or coming up in the next few months. So all in all, our couple promises that we're making here is one, we have full coverage. So any workload that you use today in the Azure cloud, you can enable encryption at rest for the data. This is number one. Two, we're moving to a model where all data in Azure is going to be encrypted by default, whether you like it or not. So this is already in flight and should be done again before the end of this year. Just re-encrypting, more than petabytes of data takes some time, but this is in flight and should be done this year. And then the third promise that we have is that really any workload that we have here will allow customers to manage their own keys, their own data, and their own and transparency relative to how they access the data and manage the keys. So that's, I think, really just the money slide on how do we look at our encryption at rest across all the workloads in Azure. And again, to provide you the insights that pretty much every workload today supports encryption at rest, and you can ensure that whenever your data hits the disk, no matter what data center, whether it's the US, Europe, sovereign clouds, the data is encrypted and can be controlled by you. So that's at a very high level. I was told I had 20 minutes and leave you time for questions. So that's the high level. We can go down into more details into some of the workloads, or I can just open it for questions. Anything? Yes.
Also apply to any Office 365 hosting that might be in the Azure cloud?
Okay. So the question is whether encryption also applies to Office 365 workloads that store in the cloud. So Office 365, it's not covered here, but Office 365 is also enabling encryption at rest for all of the workloads that they support. The architecture that they're using, again, we work very closely, Azure and Office these days, so it's pretty easy to ensure that we're full alignment relative to when data is encrypted and how it's protected. So similar thing, there's work done in Exchange, some of the others to enable encryption using customer managed keys and Key Vault, same model as the other workloads. Same for SharePoint, same for the other workloads. So yes, absolutely. Another point to make, and that's also going to be relates to Exchange or some of the other Office applications, is that in addition to what we call the tenant data encryption, which is what all of those services essentially perform, we also encrypt all of the compute hosts. So essentially, all of the infrastructure that Azure runs on, whether it has customer data or not, is also encrypted at the host level, meaning that our compute hosts themselves, our data drives, our OS volumes, all the infrastructure that runs our cloud is also encrypted, and we manage the keys for our own purpose, such that even if it's not a customer data, but it's infrastructure data, and we're losing any of our disks, then again, it's also protected. So yeah, good question. Anything else? Yes. Sorry.
We get a copy of the roadmap.
If there's going to be a copy of the roadmap, we're going to clean it up and we're going to put it on our public sites pretty soon. But you can take photos. It's okay. Yes. Okay, so where can we get more data on each one of those services in detail? So one, we have a white paper that we're going to be putting out in the next couple of weeks that actually does, in a way, it's a walkthrough to the same deck that I provided, but also goes into the details relative to each one of the workloads. And then if you look today, even if you look online and you say, well, Azure Storage, Encryption at Rest, there are papers that detail exactly how that works and how to implement it. Same for SQL, of course, same for disk encryption. So you have pretty detailed documentation for each one of those workloads. The high-level kind of walkthrough of the encryption at rest architecture and everything I walked you through today kind of is going to be detailed in a white paper. We're going to be releasing it pretty soon. Yeah. Anything else? Okay, I'll be here for another 30 minutes if anyone have any more questions. Thank you.